So I'm about to do the Chapter 4 practice test. I have these at my fingertips just in case I need them. The DRDT formula for the volume balloon word problem, the DADT formula for the ripple in a pond word problem, and the implicit differentiation for XY. Well worth your note cards if you get to use a note card. I'm not going to develop those again. So problem 1, there's no algebra to do. It gives me a picture of a graph on a continuous closed interval. It asks me to find the absolute maximum and absolute minimum. Because there's no algebra to do, we probably should write the answer nice. So the 2 points that I circled, they're higher than any of the other points. These are considered the absolute maximum points. The point 0,4, it's a relative minimum, but it's not the absolute lowest point on the graph. So I'm not going to include it in my answer, even though it's a minimum point. In this kind of question, we want the top and the bottom for our answers. And this point, -2, -4, is actually the absolute minimum. So when I go to write my answer, that point 0,4 is a distractor. It's a relative minimum, not an absolute minimum. Relative to anything close to it, it's the lowest, but it's not the very lowest on the graph. So when I write my answer, I split the x's and the y's up and write something that's reasonable. For the absolute maximums, I said the absolute maximum, I abbreviated maximum, said which is y equal to 5, which occurs when x equals positive and -1. I don't really need the word which occurs. I can abbreviate quite a bit. As long as you have both the y and the x value are values with the word that tells me it's a maximum, I'm good with it. Similarly, for the absolute minimum, the y coordinate of the absolute minimum is actually the absolute minimum, and I need to include the x as well. So that's all there is for number 1. 2 and 3 are finding absolute maximums and absolute minimums with functions without the benefit of a graph. So for these problems, I'm going to find the first derivative, set it equal to 0, search for critical numbers, and any critical number that's between the given range, I'm going to put in a table that it also includes the given range. So I started off making a table, and I'm going to finish up this table in terms of the x columns by finding the derivative, setting it equal to 0, and any values that are critical numbers between 0 and 4 will go in this x column. The derivative of 2x cubed is 6x squared. The derivative of -54x is -54. I'm going to solve this and set it equal to 0. Let me factor out a common factor of n 6 and set it equal to 0 simultaneously just to save a line. I need to set it equal to 0. It needs to be factored. When I factor out a 6, I'm left with an x squared minus 9. And that x squared minus 9 factors into x plus 3 and x minus 3. Technically, I should say take each factor and set them separately equal to 0, but realistically, I should probably do that in my head. There's no real algebra here that can't be done in your head. The first variable, the 6, because it doesn't have a variable, you don't get a solution. The x plus 3, when you minus 3 both sides to solve for x, you get x equal to -3. And this is probably going to be, if I graph the full function, the x coordinate of a relative maximum or relative minimum. I'm not sure which, but I'm going to ignore it because it's not between 0 and 4. I'm only asked to look at the region of this graph between 0 and 4. And then for my last x minus 3, when I set it equal to 0, I get 3. I'm going to include it. Now for each x, I'm going to get a y. I'm going to do 2 times 0 cubed minus 54 times 0, and 2 times 4 cubed minus 54 times 4, and 2 times 3 cubed minus 54 times 3, and I'm going to get a y value for each. So first one, 2 times 0 cubed minus 54 times 0 is 0. And then second and enter, so I don't have to type that whole line again. back over and change this 0 and that 0 to 4 for my second line in my table. And your table doesn't have to be the same order as mine. You could have the 3 at the top or in the middle. It makes no difference. I'm just needing the ability to calculate each y individually. And it's nice to be able to look at the y's together to figure out which is the smallest and what is the largest and what needs to be ignored. So for this, the 0, 0 must be the max point because the y is the highest. The 3, negative 108 must be the absolute minimum point because its y is the lowest. So I typed up my answer. I just wrote split the 0, 0 up between the y and the x, split the negative 108 and 3 up between the y and the x, and just wrote something that was suitable for an answer. 3 will be on the test, and I want an answer with an E as opposed to an answer with a decimal. But I might need the decimal to figure out what is the max and what is the min. But let me start my table. My table is going to have negative 2 and positive 2. I already know the table is going to have negative 1. You may know that too. But let me do the derivative manually using the product rule. So I wrote the first factor of x down, the second factor of e to the x. The derivative of x is just 1, and e to the x, we've done it a couple times. It's its own derivative, so I'm not going to develop that. That's something that's worth having in your memory or having on your note card. And then I'm going to multiply, cross multiply down, and get x times e to the x. Put a plus sign down, and then cross multiply up and get 1 e to the x. I'm going to factor out a common factor of e to the x and set it equal to 0 because those both need to be done. When I factor out a common factor of e to the x, I'll be left with an x plus 1. Now I'm going to set the e to the x equal to 0 and the x plus 1 equal to 0. E to some power can never be 0, so it doesn't give a critical number. X plus 1, when you set it equal to 0, you get negative 1. For each of these y's, I'm going to write the proper y that's suitable for my answer, and then I'll do decimals for each in a little bit here. So I have an x and a y. The first y, I'll do f of negative 2, and plug negative 2 in for both of the e's. So it's going to be negative 2 e to the negative 2. That's the same thing as negative 2 over e squared. Second y, f of 2, is positive 2 e squared. And that is just 2e squared. There's no need to rewrite that. Third y, f of negative 1, is negative 1 e to the negative 1, which is negative 1 over e. When I go to write my answers, I'm pretty sure that this is the maximum point and this is the minimum point. I want the e's in my answer and not the decimals. But realistically, without decimals, I can't really tell which is the bigger. So let me do negative 2 divided by e squared. This first decimal is negative 0.27. And then 2 second e squared. My second is 14.8. It doesn't matter in terms of accuracy. Just need to be able to tell which is the biggest and which is the smallest. And then negative 1 divided by, second and divide for e without an exponent, negative 0.37. And that is, this negative 0.26 is bigger than negative 0.37. So the last row of my table is my max. The middle row of my table is the min. And again, when I write my answers, I don't want the decimals, I want the e's. So when I wrote my answer, I split the maximum point up between its x and its y. I split the minimum point up between its x and its y, and I wrote a nice-ish answer. In problem 4, somewhere in here, it should include, I forgot to write this and I added it and I forgot to add it on the review. Somewhere in this problem, and I'll go ahead and add it later, it should say find the dimensions of that maximize the area. Find the dimensions that maximize the area. And This is the word problem that comes on the test from section 4.3. Just one. And we did 2 word problems. They both had a campground owner fencing in an area. One had a river, the other didn't. Usually on the test I put the river. So pictorially what's happening in problem 4 is there's a river and a campground owner has 100 meters of fencing, and he's going to build a rectangular region that butts up to the river, but we're not allowed to put a fence across the river. So we're going to build 3 sides. The sides that are perpendicular to the river I usually write as W's. The sides parallel to the river I usually write as lengths. And the one length that we're building plus the 2 widths are going to use all 100 meters of fencing. So for part A, I'm supposed to create an equation and solve it for L. And I'm going to start off by doing the one length plus the 2 widths that are being built equals 100 meters. And now I'm going to subtract 2W from both sides. And the answer to part A, the length is minus 2W plus 100. Part B wants me to write an equation for the area. And even though I'm only building 3 sides, this is still a rectangle that has 2 lengths and 2 widths. The area of any rectangle can be found by multiplying the length times the width. And for the answer to part B, I need to change the length to minus 2W plus 100. So I'm going to make the area as minus 2W plus 100 times W. And I'm going to multiply the minus 2W by the W and the 100 by the W and get my area equation as minus 2W squared plus 100W for my answer to part B. For part C, I need the upper and lower bounds on the width. Since I have 100 meters of fencing, I'll divide it by 2 because I'm building 2 widths. The upper bound on my width is 50, and my width can't be less than 0 because dimensions widths have to at least be 0. Actually, they probably need to be more than 0. So for part C, I could just say I'm going between 0 and 50 meters for the width, or I can say the width is in between 0 and 50 meters using these less than signs in the nested inequality. Both of those would be right. Parts D, E, and F want me to find the maximum, and I'm going to do that as an absolute maximum problem. So to find the width that maximizes the area, I'm going to create a table. In the left-hand column, I'm going to have the width of 0, the width of 50 that I've gotten from my answer to part C, and then any critical number that's between 0 and 50. And the right-hand column is going to give me the corresponding area. I'm going to take the derivative of the area equation. I'm going to get area as minus 2 times 2, or 2 times minus 2 is minus 4. Lower the exponent by 1 and get minus 4W. The derivative of 100W is just 100. I'm going to get a critical value by taking the derivative and setting it equal to 0. I'm going to minus 100 from both sides and get minus 4W equals minus 100. Then I'm going to divide both sides by minus 4 and get a critical number of 25. That's what the answer is going to wind up being. Now for each width, I need to get its corresponding area. I'll do, using the area equation and not its derivative, I'll do negative 2 times 0 squared plus 100 times 0 for the first value, and then negative 2 times 50 squared plus 100 times 50 for the second value, and then negative 2 times 25 squared plus 100 times 25 for the third value in my y column. I'm looking for the absolute maximum, and it's going to be the W that corresponds to the biggest number. The first two just come out to 0. So negative 2 times 0 squared plus 100 times 0 gives me an area of 0. And then if I, let me just type it over, negative 2 times 50 squared plus 100 times 50 also gives me 0. Now I can just second and enter and go back and change the 50 to 25. Needed to have an exponent of 2 here. Oh, no, I didn't. It's right. I'm messing my mind up. So that looks like negative 2 times 25 squared plus 100 times 25. So this is the value that's the maximum point, or the absolute maximum point. So it gives me 2 bits of information. It tells me the width that gives the maximum area, and it tells me what the maximum area is. For part D, the width that gives me the maximum area, the number is 25, and when I look at the problem, the units are in meters, and I need units with my answers because it's a word problem. So I'm going to tack on the number meters. I know the answer to part F already, and that you can see part F, but the maximum area is going to be 1,250 for the number, and areas are always square units, and it's square whatever the lengths are. In this case, it's square meters. And lastly, I just need to find part E, the length. I'm just going to use the length equation that I found in part A. The length is minus 2w plus 100. And I'm going to plug in 25. Get length is minus 2 times 25 plus 100. I don't need my calculator for that, but you can use your calculator to get that it's 50. The answer to part E, the length that I need, is 50. And then the units are either m for meters or the words meters written. So a couple more word problems, but that's the most involved one with all the parts to it. Now we're going to do some implicit differentiations. For problem 5, anytime I take the derivative of a term that has a y, I tack on a dy dx to its derivative. The derivative of y squared would naturally be 2y, but because I'm taking the derivative with respect to y, I tack on a dy dx. The derivative of minus 3y, it's a first power term, its derivative would just be its coefficient of minus 3, but because it's a y, I tack on a dy dx. And to the right-hand side, because I'm taking the derivative of x and that variable is x, I don't need a d on the right-hand side. This is just going to be 15x squared. Now I'm going to factor out the common factor of dy dx. And then I'm going to divide. And when the denominator has a plus or a minus in it, in this case the denominator is going to be a binomial, you can't really reduce unless you can factor out a common factor to reduce with the numerator, or unless it matches the numerator identically. So this answer is not going to reduce, and I don't really know another way to write it. When I was doing the videos in 4.3, I know I was rewriting answers multiple ways, but that usually implied the denominator didn't have a plus or a minus in it. Then you have flexibility. For 6, I need to do this derivative, and then I will have this on my note card if I was getting to use a note card. The derivative of xy is x dy dx plus y. You can recreate this if you want to, but it takes time, and I know what that equals to. It's going to equal the same thing every time, and since I needed it a couple times, I just kept this handy. That's the left-hand side using the product rule. Well, I used the product rule to develop it. I just cheated and stole it. On the right-hand side, the derivative of 6x is 6. The derivative of 8 is 0. And now I'm going to subtract y from both sides and divide by x. When I subtract y from both sides, I probably want to write the y first. But if you wrote it second, I could hardly care. And now I'm going to divide by x, and I could make small fractions or I could make big fractions on the right-hand side. On this right-hand side, I could have written minus y over x plus 6 over x. That's legal to do. Anytime you could write the numerator over the denominator. It's not particularly productive because neither one of those fractions reduce, so there's really no reason to write it like that. But this would be an okay answer. And if you wanted to, when you go to write your answer, in this numerator, if you write this version, you can factor out a -1 and write -1 in front of a parentheses in the numerator. And when you factor out a -1, you flip signs. The -y would turn to +y. The +6 would turn to -6. Like in an intermediate algebra class, that's a skill that we make a big deal of and saying we don't want the first term to be negative. In calculus, not so much. We don't really care. Problem 7 wants me to find an equation of a tangent line, and it uses the same function that I had when I did is it? I don't know. I thought it was the same function as, let me just do this derivative. I need this derivative, and I think I calculated it, but maybe I didn't. I don't see it handy. Let me calculate the derivative. On the left-hand side, I'm going to go 2y is the derivative of y squared, but I took a derivative with a y, so I need a dy dx. On the right-hand side, the derivative of 3y would just be 3, but because I took a derivative with a y, I need a dy dx. The derivative of 2x squared is 4x. The derivative of -2 is 0. I'm going to minus 3 dy dx from both sides in my efforts to find the derivative, or at least to solve the derivative for dy dx. So this gives me 2y minus 3. It gives me 2y dy dx minus 3 dy dx equals 4x. Then I can pull out my common factor of dy dx. I get dy dx times 2y minus 3 equals 4x. And then I can divide both sides by 2y minus 3 and get the derivative if it's not already given to me, or if I didn't already compute it for another problem, is 4x over 2y minus 3. Problem 7 wants me to find an equation of a tangent line, and in order to find an equation for a line, I need a point, and the point is a freebie. It's the point 1, 3. I need a slope. The slope's by no means a freebie. I need to use the derivative. To find the slope, I'm going to use the derivative, and into the x for the derivative, I'm going to plug in 1, because that's the x coordinate of the point. And for the y in the derivative, I'm going to plug in 3. So my derivative is going to be 4 times 1, which is 4, over 2 times 3, which is 6 minus 3. So my slope is going to be 4/3. So now I'm going to find the equation of the line using y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. On the right-hand side, it's going to help me if I write the 3 in its fraction form for what I have to do next. And then I'm going to multiply 4/3 times x to get 4/3 times x, 4/3 times minus 1 to get minus 4/3. And now I need to set it up to solve for y. So this 3 that I snuck and wrote as a fraction, I'm going to multiply by 3 over 3. This is going to give me y minus 9 over 3 equals 4/3 x minus 4 over 3. And I'm not matching with my answer. This is troubling to me, but I don't know. Let me make sure I haven't got a mistake here. The slope is definitely 4/3. And then I add 9/3 minus 4/3. There's an answer off screen that I just think is wrong. I'm going to stare at this for a few more seconds. Don't like having wrong answers on my video. I have this written on my screen, which troubles me because I worked this out already, but I don't believe this is right. So let me make sure my plugging 4 in for x and 2 and 3 and for y. 4 times 1, 2 times 6 is 6, 6 minus 3 is 3, that's fine. Y minus the y coordinate is m times x minus the x coordinate. I think this is right. I don't see this answer being right. There's a fluke that I made a mistake that I just can't see right now, but I believe this is right and that's wrong. You'll tell me if I actually have a mistake here that I just can't see. A lot of times when I make a mistake, I can never see my mistake. Happens all the time to me. So if there was a mistake there, I apologize. I'll try to fix it. So problem 8 is the concentric circle problem. And for the concentric circle problem, this is the formula I'm going to need. We did all the work for this already. I'm just going to take the information that's provided, not go through all the steps to recreate this formula. This is exactly the problem from the section 4.4 with just some different numbers. The important numbers here are the radius is 3 feet. So the r is going to be 3. I'm sorry. When the radius is changing at a rate of 3 feet per second, that 3 is not the radius. It's how the radius is changing with respect to time. That 3 is a dr dt. It's how the radius is changing with respect to time. This 6 is actually what the radius is. And we're trying to find at the rate with the area of the water is being changed. I'm trying to find dA dt. So in this concentric circle of a pebble dropped into a pond problem, I always give you the r and the dr dt. I ask you to find dA dt, and this is the formula that I'm going to use. No need to recreate this since we already have it. So I'm going to use the formula. The rate at which the area is changing is 2 pi r times dr dt. We'll have to get some units on this, but the rate at which the area is changing is 2 pi. The r is 6 feet. The dr dt is 3 feet. This is 36, I think. So I get the area is changing at 36 pi. Now I need units. Because this is area in the numerator, I need square units. And the numerator, the units are feet. This area, the units are going to be square feet for the numerator. It's square because it's area. It's feet because the lengths are in feet. And the time is in seconds. So this is going to tell me that the area is changing at 36 pi for the number, and then the units, I need to say feet squared per second. I can write that down if I wanted to. I can say the area is growing at 36 pi square feet per second, or I could use the units like I have here. One more problem, and it's another problem where I'm just going to lift the formula from what we did in section 4.3. No need to recreate a formula that we've already created. Just now we can use it as a tool to solve the problem. So this is an air being pumped into a spherical balloon problem, and we're given the first number, the rate at which the air is being pumped into the balloon, and that's how the volume of the balloon is changing with respect to time. The first number given in problem 9, the 3 is how the volume is changing because it's a cubic number, so you can tell it's a volume. And then it says calculate the rate at which the balloon is changing. It wants me to find dr dt, how the radius is changing with respect to time. And that says when the radius is 10 centimeters. So the radius is 10 centimeters. I created this formula, I might as well use it. So I'm going to use the formula that we created when we did this exact word problem with different numbers. The rate at which the radius is changing is the rate at which the volume is changing divided by 4 pi r squared. I will have to get some units on this, but it's not particularly hard. So in the numerator, I'm going to plug in 3 for the dv dt. In the denominator, it's going to be 4 pi times 10 squared This is going to be 3 over 4 pi times 100. And that's going to give me dr dt, the rate at which the radius is changing, is 3 over 400 pi for the number. And I need to get units. The radius isn't going to have a square or a cube unit because it's not area or volume. It's just linear. And this is centimeters. So the units in the numerator are centimeters. The denominator is time, and time is in seconds. So the units for this is going to be centimeters per second. The units of the dr in the numerator and the dt in the denominator. And when I wrote my answer, I mentioned that the radius is growing at a rate of this number, and I just abbreviated centimeters per second, but you certainly could write down centimeters per second, and I'd be good with that. But an abbreviation for the units or just the units written in words, both are fine. I really hope that this problem 7 is correct. Rather than stopping the video, I'm just going to redo this problem real quickly. You can stop the video right now, but if I have a mistake, I want to catch it and not have to re-record this video. So 2y dy dx equals 3 dy dx plus, I'm not really explaining it, I'm just doing it for myself. Skipping some steps. If it's mistaken, I will explain what I'm doing. So get my m. M is 4 times 1 over 2 times 3 minus 3. That is 4 over 3. Fine. Y minus 3 equals 4/3 times x minus 1. Y minus 9/3 equals 4/3 x minus 4/3 plus 9/3 plus 9/3. Y equals 4/3 x plus 5/3. That was for nobody to read. That's the same answer that I got. I feel good about this answer. I was troubled that I have an answer written down and it didn't match up, especially because I've already done this problem, I think twice, to get it to this point where I had the answer to show on the screen. But it's definitely, I believe that answer is wrong and this answer is right. So this was a nice short review. This is usually the best test of the semester. I hope that's the case for this semester. The class average is right up close to 90.